My name is Boris, and you might remember me by participation in the competition of hacking the infrastructures, standards, etc. So I used to work with the research in the components and audit of ICS. I continue to enjoy it in my pleasure time. So, what I would like to talk to you about today. Today, I would like to talk to you not just about the views on ICS. Is it PR or panacea? Raise hands that the machine learning of ICS is a PR. Are there any such people and who believe that it's a panacea that will save from everything? Raise hands. No one. That's good. I have 20 minutes. I'm not going to talk about the exploit analysis, about analytics of CVE. I'm not going to talk about how the industrial networks are built, and I'm not going to talk to you about the structure of industrial protocols. I'm sure you know about all these things already, and if not, catch me after the presentation. I'll give a link to my report where I was saying about these things. So what we are going to do today, very shortly, about the most important cyber attacks in the ICS, and I'll tell you about the machine learning related to exploits, random selection of exploit, and from normal behavior. Does everybody remember what incidents happened and attacks? And there were many. Many is how many? But 10. If about 10, why do we do the protection? Maybe we can avoid that. Anyway, when I was working there, people were telling me, oh, we don't need to protect ourselves because there are very few incidents and we would be hardly attacked. But on the other hand, we have Stuxnet, we have a destroyer with black energy, and Iran nuclear program was hacked, and Ukraine was blacked out twice. There are several things must be noted. For the first time, the main idea that they were influencing the data of technological processes. And we are interested in Destroyer because they were using exploit for a relay of Simprotech. And this is exploit which is used with industrial network from inside. So this is a classical computer network attack, similar to it, and very few attacks. And we have a lot of CV in current time. If you take just one company, just one line, for example, WinCC for Siemens, at 2016 there were about 50 vulnerabilities. If you take 7, it was about 26 vulnerabilities. It's a lot if you take a small part of ICS components. So what do we have today? What do we have today? We have a lot of vulnerabilities for components. No incidents, but a lot of vulnerabilities, and not everybody patched them. And also we have such thing from Stuxnet. Influence on technological process, and many words were mentioned before. If you don't do that, it may lead to catastrophic consequences, and it will not be detected immediately. So what do we want? We want to find exploits, and we want to find malicious impact in our data. What do we have in real life? It's great. We have ICS components, all the vendors develop their own components. We have component lines. We have a lot of them, and all of them are black boxes. Some have customary processes, and what we can't do in normal network, put an agent onto ARM who would track what actions were made there. But thanks God, or maybe not, the industrial protocols do not support encryption, and if they don't support encryption, what we can do? Intercept and analyze network traffic. So, people said many times that we have a certain data integrity, it must be traced. I was used to work on vulnerability tracking, and I have a different approach to that. I'm not going to jump ahead. We have an exploit. What we can do about it? How this works? We have exploit. We write new IDS rule. It works, but there are some limitations. Not everybody exchange information on exploits that were found, and also we can detect only those attacks that we know. If we don't know, we don't do nothing. What we can do about it? So let's try some classical computer networks. We have certain base of Silk code. Is it going to work or not? It works in classical network, but doesn't here because there are very few exploits. Very few exploits. We have a lot of CV, but very little exploits. So let us take a traffic that we have from the network and write a rule for it. Understand the protocols that we have, but again, it would be labor costly for our reverse network protocols. Not everybody can afford it. And then we have a great thing. Instead of doing the reverse of network protocols, why not learn? And the question is, what is the normal state? Who of you come across solutions using machine learning? Except lab, because it would be launched next year. Not everybody? Okay. Can you share what is the solution? It's not exactly that. That about a data flow, not exactly what I was talking about. Once again, as I was writing books for vulnerabilities, I'm observing how the POC is working. I see the standard protocols are working, and I see that my POC doesn't look like the standard traffic. Why can't we understand the standard traffic and use to detect the anomalies? And with that, I created testbed consisting of standard components you can find in Siemens, which are controllers, ICS components, SCADA Win CC, for example. So, and then I was training with following methods like SVM, then artificial neural networks, and RNN, and then what we come to now. I was not detecting impact in real data. I was trying to detect only exploits. Malware upload 730, brute force. Who knows what we can do with controllers on PLC at the current moment of time? That's all. But can you give specific examples? Frico, what people do now? Yes, exactly. People can do things like using quality controller proxy server so that they would split among the controllers and they can mine bitcoins. And now important point. That's the percentage of the detected malware. 94% is a lot or not. It's important to say I'm taking a percentage. As I launch exploits myself, I know how many bytes in total from the malware packages or traffic. I see how many were detected. They take these bytes, divide onto all the bytes from malware traffic, and have a package. 94 to detect the malware traffic is a lot or not? Yes. Malware traffic or malicious traffic. We found traffic which is malicious. True negative for this case. Sorry, no microphone, no interpretation. No, there's another point. It's very close to stand. It's 94. 94. And now 94 multiplied by 2 and then 1/20th. 1/20th, I mean 94 remains about 6% left. So it means that 1/20th malicious traffic will not be detected. And this is bad. On the other hand, I'm not telling you how the exploits look like, because often exploits use the valid packs and they could be detected as valid traffic. But there is another point here. Why using traffic-based learning? We don't want to get the reverse analysis of how it is all set up there. And if we want to find exploits, it could be an emergency, and there's a traffic about the emergency of equipment, where we are going to bring it to, right? I brought it to valid traffic, and I showed that if you don't use this traffic for learning anyhow, and it may not be in a real normal sampling, we have the lower value and high false positive, which is also not good. It is not good if you don't take into account the character of the exploits which are available for the ICS components and what traffic could go there. Then, what else we want to do? What other possibilities we have? Unfortunately, there are no other things related to machine learning for traffic. You mean the model, training model? No, these are attacks. What I mean, what else could be detected? And actually colleagues all spoke before about the data integrity. The first thing which allows to detect the exploits themselves. Not all exploits could be detected during operation. It's not very good with percentage of detection. So the software and the things which is going to be in open access soon, I recommend you do only forensic. Not make the protection using the library of malware traffic, because it can kill the valid traffic. Is it clear? Yes? But one more thing. It allows to find runtime, picking up from traffic and writes POCs for one time that we already have. On the other hand, in this case, we are not tracking the integrity. For integrity, other methods are needed, and colleagues mentioned about them. I'm not going to tell you about specifically the research made. You can read the research following the Andrei's links. You need to understand here that it allows us to find anomalies in data, but doesn't allow us the attack in the moment of attack.
so we can forecast the normal behavior and find out where their normal behavior appears. So now we are coming up to, well, are there any other research on this topic? And I will tell you about the resulting opinion. Yes, there are some research, and they are pretty different, and it is the attempt to define, to detect from DDoS attack hydroelectric power stations. Actually, SMP flood inside of the system. Well, that's the assumption they take. So we'll get rid of this and take other researches which are more or less integral. I mean, have the integrity of data. Is machine learning a panacea or profanation? Or who considers that it is the profanation? Are there such people in our audience? Yeah, actually, machine learning enables us to solve a particular range of issues, and detecting the exploits is a part which we can use in this area. It enables us to find out so we learn new exploits and find out how to protect all those complexes of ICS which did not undergo such an attack. And we are able to find anomalies which are not being actually traced pretty extensively. Andrei will tell you more about it if you ask him, which enable us to find not only attacks, or not merely attacks, but at the same time errors in implementation of a technological process.